All right, hello friends. We're doing another Leetcode interview today. I'm going to be choosing an algorithm, easy as is tradition. Still rusty, so it's always good to get warmed up. And you know what? I've been seeing easy questions even when you're interviewing for senior positions, so don't knock the easy questions. They can tell quite a lot. So what we're going to do is we're going to be using a Google Doc over here. And yes, this is pain because you do not have access to any of your IDE autocompletes or all the syntax highlighting. In real life, you probably won't be doing this, or if you are, you're a masochist. I think it's important to practice with this though, because a lot of companies will still have you interview with something equivalent to a Google Doc or Notepad. Or if you're doing it on a whiteboard, you need to kind of have everything internalized. I think the hard part with IDEs is you don't realize how much you're relying on the IDE until you don't have it. All the simple things like autocomplete, the closing of parentheses, even just how to read and look at code. So try not to get too used to using an IDE, and it'll definitely help you out in your interviews. So let's see what we get, and I'll start the timer. And it looks like we have 830 positions of large groups. So in a string, S of lowercase letters, these letters form consecutive groups of the same character. For example, a string like S equals these characters has the groups A, B, X, and Z, and Y. A group is identified by an interval, start and end, where start and end denote the start and end indices inclusive of the group. So for example, X is at interval 3 to 6 because it's on the third index and the sixth index with 0 index starting. A group is considered large if it has 3 or more characters. So return the intervals of every large group, sorted in increasing order by start index. So we're given an input of S. We return the output of 3 through 6. That's the interval of it, and that's the only large group. And then we get a next one, and then none of them are large. And then we get an example here, which shows also the question I was going to ask is the input sorted? We do have consecutive groups, so this isn't about the number of characters in the string. This is about the consecutive groups of characters within the string, which is really good to hear because that means this becomes more of an iterative question than any sort of dictionary-based or grouping-based system. So in this one, we have D, which goes from 3 to 5. We have E, goes from 6 to 9, and B, that goes from 12 to 14. And it did say sorted by increasing order by start index. Okay, not sorted by the character. That's good to see. Otherwise, we'd have to keep track of the groups. Instead, it's just by the start index of the group. So this is great. I think what this means is, let's see. What I'm starting to think about is basically iterating through the string. So before we even make any solution, is it possible to do this in better than O of n time, where n is the length of string, time O of n? Can we beat that? I don't think so, because you have to look at is the best possible time complexity. Because even if the string were sorted, well, if the string was sorted, maybe we could do a little bit better actually. But it's not a sorted string, as they just showed in the third example. So the best thing we can possibly do is check every single character only once, or at least on the order of n. Space complexity, the best we could possibly do is going to be 1, is the best possible space, because that's just what it is. And in this case, it is not exactly possible here, because in the worst case, we might have up to, I don't know, let's say k groups. Not true. I don't know if it would be k. We might say since we return all groups or all ranges, the best it can possibly be is, like, let's just say we had a string that was AAA, BBB, CCC, so on and so forth, and it just repeated for some very large string. We would get groupings of 0, 1, 2 like that, and 3, 4, 5, and so on and so forth. And this length would be equal to length n. This would be equal to n divided by 3 times 2, something along this lines. But more importantly, all that means is we're going to be going to O of n complexity at the end of all this. So in this case, best space complexity is O of n. So we haven't even written an algorithm yet, but we already know what the best space and time complexity is for this thing. Now, can we come up with an algorithm that actually does that? To be determined. I'm pretty sure we can, though. So let's start thinking about that. So approach one, what I'd like to do, as a human, what I'm thinking about how I do this with the string is I would be iterating through the string one after the other character, keep track of the current character for the group, and increment a count for that group until I reach a new character. And I'll also keep a pointer to the start of the group of the new group, and once I reach a new group, I know the end of the last group, and check if that count is greater than 3 or greater, and which means it's large, and if so, append it to my output list. So and then we finish iterating through the whole thing. So at the end of this, we have an O of n and O of n output. So let's call this large groups. And our input's going to be a string s. And our output's going to be a list of ints, it looks like. And O of n and O of n time and space for n chars. Yeah, that sounds about right. So let's do this. So let's call our output empty, and let's quickly think about any sort of edge cases. What if we have an empty string coming in? We'd want to return an empty output out, I guess. We could ask the interviewer if they want anything special for that. What about if we have, hold on a second. Yeah. What if we have something that doesn't fit into memory and we're passing in, I like to harp on the idea of streaming an input because that's just such a fun extension you can do as an interviewer. When you have a simple enough question like this and the interviewing candidate just completely dominates the question, we can just start probing a little bit more to see how much more they can do. And it makes for a really good, what's called packet for the candidate at that point. So worth learning, I'd suggest. But we'll get to that in a bit. Let's make sure we can actually solve the question to start. So let's just say can it fit all in memory? Since this is Leetcode, the answer is going to be yes. Will the string always have valid characters? In this case, again, Leetcode, always yes. If not, maybe the interviewer could say, if you have an invalid character, just throw it out or ignore it, or just raise an exception. Many options here. The important thing is just talking it out with the interviewer. All right. I think we have this idea, iterate through list, track start index, track start of group, count of group. Let's init start of group, count of group, track start of group, count of group. If char same, increment count, else close group, if good, if large, append to output. That's essentially the logic I'd like to go through here, and we can kind of confirm we have O of n over here and O of n output here. Well, O of 1, but becomes O of n space here, sorry, is what I'm trying to say. So how do we turn that into this? Let's create our start index. It's going to be equal to 0, and our char is equal, well, let's just call it char is equal to string 0. So step 1, let's do a quick check. If not string, return an empty list. And that just handles the empty case of a string. Now we can do something like this safely. And what we're going to do is for char in string, and let's just make it nice and easy to read. If the char is equal to current, count plus 1, so we need a count also. And the start index is 0, that goes along with the current car. That's how we initialize it. Else, and they want us to choose the index, the end of the range to be inclusive. So it'll be the previous index. End index is equal to, we actually need the index here, so we'll enumerate, which provides us the index into the string as well, is equal to I minus 1, the previous one. And if, actually, do we even need count? We really don't, because we can just use the start and end index and just calculate them together. Well, that's an optimization we can come back to in a minute. So, all right, if count is greater than or equal to 3, then we have a large group. We can append it and move on. And hopefully you guys can still see all this. This is getting all the way over to the right. Let's keep it over there and see how we're doing. So what we want to do is append a start index and the end index, and that's it. And now at the end, regardless of whether it was a large group or not, count equals 0, start index is our current index, and that's all there is to it. And then at the very end, we return our outputs, and we should be good to go. So what I'm doing now is just doing a quick once over. I've kind of talked out loud with the interviewer what I'm intending for this to do. Oops. Trying to avoid burping on camera. All right, what I'm trying to do now is just look through the code, make sure I don't have any errors, and then I'm starting to think about any quick optimizations that I could do. So one we had talked about was count. Is there any reason we don't want to track count? Like we could just use the start and end index instead of count, and then we just append that directly, and that way we don't have to worry about recentering it, and then we could just do a check for if the char is different. I kind of like that. I think it does make it a little bit cleaner. So let's see if we can do that. Let's just say if the char, so let's keep this here just in case I'm wrong, and do some, because the beauty of using the doc is minor optimization, remove count, is we can always go back to that one, and that way we have something that interviewer can look at, and as well as us if we need to backtrack. So what I'd like to do is get rid of this count concept. And so instead of checking for count, we check if we're not same. We create the count, and the count is just equal to the end index minus the start index. So in the case of, let's say here, start index, end index is -1. So 5 minus 3 here would be just 2, but really it's 3. So we would have to add 1 more on top of it. But instead of just doing that, we can just take the current I, which is the next character in the string. This gets us to actually a interesting point. What do we do at the end of an array when we have, say, we haven't checked what happens at the end? We need to close a group. So here, at the end of an array, if the count is greater than or equal to 3, we still have to do a output append. So the end index is equal to the length of the array. And we could technically use I again, but just for clarity, we're going to not do that because who knows what happens to I in the meantime. And start index was set correctly. So if the count is, oh, this does not go inside the loop. Sorry, this goes out here. if the count is greater than or equal to 3, we still have to append this large group also. And then we are actually golden. So good thing we kind of thought about that as we were going through this iteration. We don't need to keep track of count anymore. A lot of these things can be cleaned up by putting inside, but just for clarity, we're going to keep them as separate variables. Yeah, all right. So here we're doing an O of n sweep, iterating through all the characters, O of 1 check, O of 1 math, and creating an output. And in the worst case, it's once creating this is O of 1, but and appending it is O of 1 as well to a list. The overall length of that list will eventually be O of n, but O of 1 opts otherwise, including these. Okay. And let's just make sure add end close out last group if needed. One thing we haven't done that we forgot is updating cur at the end of this. So that was one thing I needed to add, equals the current char. So that's important if we want our group to actually track the latest value. New group started. Kind of the most critical component, one might say, actually. So make sure not to forget that. I'm updating both the old and the new just so we have something to fall back on. But from what I see here, I think we should be good to go. Let's just make sure we have our O of n, and yeah, there we go. All right, how much time have we had done? About 16 minutes. As good as time as any. Let's put this inside and see what we got. I'm just copying the code over to here. And we have a bunch of tabs, so we need to fix that. This is not going to be clean, unfortunately. Luckily, I can just look at the code over here. So one little thing you can do as a trick is if it's too indented, you can just kind of switch it around and just do a check for the opposite and continue on that one. That way these guys can all why doesn't it let me? All right, there we go. So let's just do that here, just because I like to have a little bit less of an indent. And okay, and then here, if the count is greater than or equal to 3, it's a large group, and append it to our list. Since we're iterating through the list in order, our start indices will always be incrementing, as is requested by the thing, by the interview question, increasing order by start index. 3 or more characters. What makes it a group is if the character values are all the same. And the intervals start through end inclusive. Okay. Sorry, burping all over the place. All right, before we run, just trying to make sure we don't have any crazy edge cases that I'm missing, but running the test will definitely do it. Just noticed another thing. You guys may be noticing a lot of these little off by ones. Feel free to yell out loud. I'm sorry I missed it. String S, that's fine. Nothing else is passed in. Start index continues, different char. This way it doesn't get too deep of a nested loop. We still need to close the these are all valid. Start index was from there. Or there. Okay. Let's run and see what we get. I expect this to work. So that's good to see that they accepted the test cases all passed. Very happy to see that. And let's submit it and see what we get. Come on. Oh, yep. Always good to see when it passes on the first go. So we were accepted. Runtime is generally irrelevant as long as you're within the ballpark at these kind of questions for these kind of sizes. The Python code itself, the interpreter in the backend will change the speed and memory in ways that have nothing to do with the algorithm, unless you're extremely inefficient. So really happy to see that. And I think this is a good question that shows the value of kind of talking your way through the problem, thinking about how the groups are formed, how you're tracking that. This idea of building substrings or tracking substrings is really important because there were other ways one could have approached this. I didn't really talk about it here, but so this is the one we ended up doing. But another approach, we might have built strings for every as we iterated through the list. Or we might have built strings as we iterated through the list, or we might have done string replacement, etc. All of these are technically valid in that you will get a solution, but they're generally pretty inefficient in specific ways. When you're building a whole new string, you're using O of n space immediately. And this is larger than this O of n down here, because this one is a function of the number of groups. So one could even argue that we could call this O of k time space for k groups, large groups. And if the number of groups is a lot less than the number of characters, this becomes a lot more efficient than here, where we are immediately using O of n space. If k is much less than n. So keep that in mind. These kind of little things really do matter. And especially when you start to do things like string replacement. If you were to try to you take your first char and then you just do like a string to replace all of the a with nothings. I've seen people do this, and as an interviewer, it really bothers me, and I don't have a really good explanation for why. Please let me know in the comments if you can explain it a little bit more clearly than me. But my issue with this is that first of all, you're having to either modify the input or you're creating a whole new copy. So that's the O of n space immediately. You're also doing a lot of extra operations for something that could be done a lot simpler. So I think that's where I start to get really annoyed. You're taking advantage of the logic that string.replace does without truly thinking about what it's doing. So string.replace is essentially iterating through the list, doing string comparisons, and then creating a new string through some form or fashion, either as a list and then merging it all together at the end and returning that. So if you know that, why aren't you just doing it yourself in the most efficient way possible? In terms of developer time, maybe it saves something, but it becomes a pretty brittle solution. I have a lot of strong feelings about this. Maybe this might be just a me thing. I'd love to hear if anyone has any feelings on this one as well. I think from what I've seen in interviews, if you were to start doing string.replace and string manipulation of that sort when it's not necessary, that's automatically kind of a ding against you because it shows that you don't really care about that. If you can confidently argue it to the interviewer, I'd say if I saw this coming to me from a candidate, I would ask them, why are you using string.replace? And they would explain why they're doing it. I was like, do you think that's the most efficient way to do it? Could you do it without? Or is there a reason you wouldn't want to use string.replace? And if they're able to explain the logic of why string replace is iterating through the thing and it just saves them developer time, but it's technically the same as iterating through it themselves, and it's not the main thrust of the question, in this case, I probably would tell them, let's not use that because it kind of sidesteps the whole question's point entirely. I don't know. I don't care about how good Python string.replace is. I want to figure out what the candidate is doing. So, but if they can't explain that, which honestly happens most of the time, that shows that they don't understand the actual logic that they're trying to do. So that's the important. It's not about being able to quickly find a pre-existing like Python library function call, because I mean, I think we could use a lot of different tricks to do one-liners to solve this problem, which would be fun in its own right, but is not the intent of these kind of questions. Like if I were interested in that stuff, I would start giving medium questions where you kind of have to do tricks like that just so you have time to solve the actual question. Anyway, that's me getting off my soapbox. I hope you guys enjoyed this question, and see you guys next time.